Welcome to aminacademy.com. In electrical engineering, let us discuss about law of electrostatics. First law, Coulomb's first law of electrostatics. It states that like charges of electricity repel each other and unlike charges attract each other. Here, positive and negative attract each other and negative repulse each other and positive charges or repulse each other. Second law, Coulomb's second law of electrostatics. It states that the force of attraction between unlike charges or forces of repulsion between like charges are directly proportional to the product of both charges and inversely proportional to the square of the distance between the centers of the charges. Here, Q1 and Q2 are different charges separated with distance r. That means from center to center distance is r meter. Now the force of attraction or force of repulsion is equal to k into q1 and q2 by r square, where q1 and q2 are charges of each point charges, and the product is directly proportional and square distance is inversely proportional. So k is a constant. Now we'll discuss further this. Here, by Coulomb's law, F is directly proportional to the product of the charges q1, q2 over the distance square, that is d square, or we can see F is equal to k into q1, q2 over d square. Now in vector form, look at in vector form, that is here force vector equal q1 into q2 over d square into d cap, where d cap is called unit vector, where d cap is unit vector, that is a vector having unit length in the direction of the d, in direction of d vector. Direction of d. Now suppose two charges q1, q2, we can say F vector 2 to 1 is equal k q1 q2 over d12 square. Now which is equal k q1 q2 d12 over d12 cube. That means you are multiplying up and down by vector d12. Now in general, that we can say use the value of k as 1 by 4 pi epsilon into q1 q2 over d square. Then epsilon is further you can write as 1 by 4 pi epsilon 0 for vacuum and relative medium epsilon r q1 q2 over d square. Here q1 and q2 are in coulombs, d is in meters, epsilon in farad per meter, then f is in newton. Therefore, here 1 by 4 pi epsilon is equal approximately the values 9 into 10 power 9. Therefore, we can write in terms of force is 9 into 10 power 9 q1 q2 over d square in newton. q1 and q2 are in coulombs, d is in meter, then f is force in newton. Q1 and q2 are coulombs, d is meter. Now let us do an example problem. Calculate the electrostatic force of repulsion between two alpha particles when at a distance d equal 10 power minus 11 meter from each other. Charge of an alpha particle is 3.2 into 10 power minus 12 coulombs. If mass of each particle is 6.68 Newton meter square over kg square. Now let us do this problem. Here the both charges are alpha particles, so both are equal charges. Therefore Q1 equal Q2 equal given 3.2 into 10 power. Q1 and Q2 are 3.2 10 or minus 19. It's not a 12. Let it be. It's minus 19. The 10 power minus 19 coulombs. D, the distance, D equal 10 power minus 11 meter from each other. Charge of an alpha particle, charge is 3.2. Therefore force of repulsion between the alpha particles are 9 into 10 power 9 into 3.2 into 10 power minus 19 into Q2 also 3.2 10 power minus 19 over 10 power minus 11 the square. So which is equal the calculation of 9 into 3.2 into 3.2. 9 into 3.2 into 3.2 is given as 9.2 into 10 power. Here 9, 19. Look at here 9, 19, 19 into here denominator have minus 22, that is plus 22, which is equal 9.2 into 10 power. Look at here 9 plus 22 equal 31 positive and This is 38. 38 is negative. Here 31 and 38. So we have -7. -7 Newton. This much force between two alpha particles. Next question. Example problem. The force between two identical charges separated by 1 centimeter is equal to 90 Newton. What is the magnitude of two charges? Here two charges are equal. Let it be Q1 and Q2. Both are equal. First, here is a force of repulsion because both are same charges. As is 90 Newton, it repels each other 1 centimeter apart. Two charges separated by 1 centimeter experiencing force of repulsion of 90 Newton. Define the variables. F equal to 90 newtons. Q1 charge of first body, Q2 is charge of second body. Both Q1 and Q2 are equal. R is 1 centimeter. Here using the Coulomb's law, F equal K into Q1 Q2 by R square, distance square. The problem says that two charges are equal, so Q1 and Q2, that is, let it be Q. So we are having Q1 and Q2 are equal to Q, that is a Q square. F equal to K into Q square by R square. Since we want the charges, solve the equation by Q. Then from that, by cross multiplying, Q square equal to F R squared by K. Then F Q equal to F into R squared by K. Then now we will use the problems, that is 1 centimeter equal to 0.01 meters we are applying, and this is 9 into 10 power 9 or exactly 8.99 into 10 power 9. The values, we are using these values and calculate Q equal to approximately equal to plus or minus 1 into 10 power minus 6. 10 power minus 6 coulombs. This equation has two possible answers, that is positive and negative. The charges can both be positive or both be negative. And the answers will be same for the repulsive Coulomb force over a distance of 1 centimeter. So, two identical charges of 1 into 10 power minus 6 coulombs separated by 1 centimeter produces repulsive force of 90 Newton. So far we have discussed about Coulomb's law. We discussed about Coulomb's law of static electricity and we did some solving problem. We have done. Please subscribe our YouTube channel.